Okay. So I think we already discussed it multiple times that the GoldenGate is a low impact and routing and uh, generally used for the heterogeneous environments to replicate your databases. Okay. So this already we have done. So what it does is, how does it replicate? It reads from the readlog files. It reads from the readlog files and put it into, and then it reads readlog files or archive files, whatever are there, readlog files, archive files, or transaction log files, and then send it to the target. Okay. So low latency would also be used in this GoldenGate as a delay in replication. Okay. So latency would be a term used in delay of replication, means I have committed my transaction somewhere around at 10 a.m. over here. So at what time it is committed in the target? Okay, maybe 10:05 or 10:10. So that 10 minutes is the latency or 10 minutes is the lag in the replication. Okay, that's the delay in the replication. Okay, so what is the idle time? Idle time is 30 seconds. Okay, so Oracle documentation says that within 30 seconds, if a record is committed over here, it should commit in the target also. But it is idle. Okay, it's idle time. It doesn't have to happen practically. Why it doesn't happen practically? Just assume I am making a transaction which is having 1,000 inserts or maybe 1 million inserts. Okay, that idle time is like you have say average on your bike or your car, which actually is not on the road, right? So why it is so? Because it shows 30 seconds only for when I have one insert and I committed it. Okay, why I do one update and committed it, but it doesn't the case in the practical scenario. You have sometimes 1 million inserts, 1 million updates or commits or deletes. Okay, I've just started sharing the screen now. Okay, so you have 1 million inserts, updates or deletes, and then you commit. Okay, so if it has taken 1 hour over there, it might will take 1 hour or 1.5 hours or 30 minutes depending on the performance of the database in the target. Okay, so it will take that much of time. So that latency will increase, that lag will increase. It reads only committed transaction. We should be very sure about. Let's just go to the third point. It moves the committed transaction. We also only committed transactions are read and written. Uncommitted transaction, rollback transactions, or would not be read, would not be written anywhere. Okay, only committed. When it's committed, it starts with processing. Okay, it fine. So it is used for high availability, zero downtime upgrades, migrations, operational intelligence. All these utilities are used. We have already discussed it. Why GoldenGate? Same thing which we discussed yesterday in the demo session. Okay, so today is the day one session. So why GoldenGate? Okay, I discussed it. Just repeating it once more. It is heterogeneous, supporting heterogeneous systems, heterogeneous platforms. Comparing with I will compare with Oracle Data Guard. Oracle Data Guard, you have to replicate the complete database. Here you can select schemas and tables. Okay, so you beneficial than Data Guard. The target database will be read-write mode. You need not to be read-only mode. You need not to replicate the complete database. It's a logical replication. So you replicate some schemas and some tables. Zero downtime migration, it is heterogeneous. You can go from any Oracle version to any Oracle version, from SQL Server to Oracle to MySQL, DB to Sybase. It is supported. It is supported in the distributed application. Maybe you have one big database that you can have multiple two, three small databases where you can replicate the data. Okay. It can also replicate in the bidirectional format. Okay. It also supports the bulk data loads. Okay, and a bidirectional format means database A to B and B to A. Across the network, it supports compression and encryption. Okay, so when the data goes from A to B, then in between it, data can be compressed, data can be encrypted, can be compressed, so that it saves the network, encrypted so that it cannot be hacked. Okay, these are the utilities you can use. By default, it doesn't compress. By default, doesn't encrypt. You have to use the utilities which it have. Okay. Provides various exception handling techniques and data conflicts. Enables fast recovery after encryption. Okay. So if there is any network outage or there is network breakdown, then there is no problem. Definitely replication will stop till that point, but there is no point in that it is losing any data. It will keep on generating the data, keep on reading the data at the source end. But once the network is up, it will start transmitting the data. Okay, so it has not lost anything. It will keep on reading the data from the source database. Okay, and putting it the trail files over in the source database. Then once the network is up, the trail files start transmitting. All these operating systems are supported. Okay, Linux, Windows, Oracle. All these databases are supported. Oracle, MySQL, IB2. These are all topologies it supports. Unidirectional. Okay, you can see the screen, right? Screen is visible, right? Now you can even reply on the chat window if it is not visible. Okay. Yes. Okay. So unidirectional, one-to-one, bidirectional, A to B, B to A, broadcasting, A going to B. So you can replicate some schemas into here, some into B, and some into C. Okay. So you have three schemas to replicate. In data warehousing, you can replicate. You can consolidate all the schemas into one data. So it's a flexible tool. You can select schemas, tables. You can select also commands as well. Maybe I don't want to replicate the complete EMP table. I want to replicate just few records. I can put a where condition. Okay, I can put a where condition where I will replicate few. Maybe if I say few like EMP table, everybody knows, right? In the Oracle database, I can say where job is equal to manager or job is equal to clerk. So only clerk records are replicated. If any insert is happening on the clerk, it will replicate. Any update or delete happening on the clerk could be replicated. Okay. It is reading the commands from the redo log file because redo log file is containing the changes. Okay. But any structural change to the database, like alter database I do, alter system I do, could not be replicated. Okay. It's a logical replication. It is not like a data cut when I do an alter table to that data file. It will not pick that command at all. Okay. It is only picking the DML and DDL commands. Okay. Any particular DML and DDL commands that are impacting the data. Okay, so it's the data replications are only impacting the data. So these commands are common for all the databases. Same commands of insert, update, delete work for Oracle, SQL Server, Teradata, Sybase. Might be a bit of change. Okay. So before going for any project in GoldenGate, just look at its exceptions as well. What are the lots of exceptions? Okay. So most of the things are supported in Oracle databases, but there are some restrictions, something which is not there in other databases like SQL Server or in Teradata kind of. Okay, so there are some restrictions, such things which are not available in SQL Server or the database. Okay, so just go to the documentation before commenting anything. But for Oracle and Teradata, everything, most of the things are 99% things are supported. Okay. So these are the three tools we're working on. These are the extra tools, GoldenGate products we can say, the extra tools which you need to purchase, you need to buy the license if you need them. I think we discussed yesterday as well. Very data is something where the databases are compared. Okay, I have a database A and B, the application is going on, the application is working fine. So I want to compare if everything is replicated fine, the data is matching or not. Right. So GoldenGate is not skipping anything. GoldenGate will not skip anything. Okay. Even if there is any error or anything is not able to replicate, it should give an error to us. But still, I'm very cautious. I'm very cautious. My database is very critical. I have a banking system. I cannot give you wrong records in the target database, right? Or somebody might be by mistake because the target is also a read write system. Okay. Somebody might have entered in the system and might have done something. So I want to compare the records. So Veridata is an independent tool which is not dependent on the GoldenGate. If GoldenGate is not installed, then also you can buy it and use it to compare the data in source and target. You have to compare table by table over here. If there is any mismatch, it will report you. It will report you, and if you say repair, it will copy the data from source to target. Copy the row from source to target. These are kind of director and monitor are the graphical tools which are there to configure your parameter files, configure all the these graphical tools, you have to type a command over here. Okay, it doesn't mean you are safe on typing the commands. You have to type the same commands. You have to do same thing, but you will do it in the command prompt. You will be doing it in the Unix shell. Same commands. Okay. Application adapters, as now Oracle GoldenGate is also combining with flat files, also reading the data from big data technologies, such things. So it has some adapters which you can use if you want to combine with flat files or Java or with big data, not covered in the course at all. Okay, I have also not done in my career as well. So you have adapters that you can combine with big data because by default it is made only for SQL command for RDBMS. Okay, but as of now, right now you can combine with big data, MongoDB, other data, big data, Hadoop technologies as well, and flat files as well. But you need to have some adapters for it. These are the GoldenGate products in addition to the GoldenGate software itself. Okay, now let's come to the most important part, that is the architecture. Okay. I quickly went through it because we have done it yesterday also, so I don't want to bore you more, because I think yoga is the new joining over here. I just want to go through for it as well. Okay, so any doubts till now? Should we go to the architecture directly? Okay. Yeah, architecture we are just starting. We are starting the architecture. Architecture we have not done it at all. Okay, so this is the architecture of GoldenGate. Okay, now out of it, just see at the bottom side. Okay, this side. Don't check it this outer side. Check it the bottom side. I told you that GoldenGate is generally used for change synchronization system. It is not like an export import where you export the data, import the data. Exporting for the batch code, right? It creates an outage. If I say sync my database with using export and import, can you sync it? No, we cannot sync it. We do an export and import. It is out of sync. Okay, maybe export take 4 hours, import take 4 hours. So already when you do export and import, it is already 8 hours delay than source database, right? But it is a real synchronization, So first you do an export and import. Or you do any initial load technology, maybe Informatica or anything. Okay, Informatica, export and import, or RMAN, anything. Okay, SQL developer. You copy the data first of all, and after copying the data, you took the particular SCA number. Okay, so first we do an export and import, and then we find the SCA number from where we have to sync. Okay, we will sync from that particular SCA number. Okay. Okay. So we'll find that SCA number. That SCA might be in the doodle log file right now, or might have reached the archive file. Don't worry. That log file should be available because the format of doodle log file or archive file is the same. So we can read it from there. In the SQL Server, the concept is different. There is no archive file over there. The transaction log file, same one file which keep on writing the data, and then it is keep on purging. I think they purge the old file, or they. I also am not very. I just worked in SQL for some time. Okay, so kind of this technology, but they don't have any archive concept. Okay, so there also you can read from that, but that portion should not be purged or should not be encrypted, kind of. Okay, So you can start from that point only. So you have to give the SCA number from where you have to start. SCA number you know, right? System change number and an Oracle DB. Even if you don't know SCA number, that is also fine. You know the time. You know the time when export import was taken, the exact time when export import was taken, right? So you know the exact time when export import was taken. Okay, and then you start your GoldenGate. Now, how to start your you got the SM, you start your GoldenGate. Now let us study about each process of the GoldenGate. How does it work? On the left hand side, you can see an extract process. You can see an extract process. What is extract process? What is extract? It is reading the data from your. It is reading the data from your Readulog files. Okay, it reads data from the Readulog files. It reading the data from the Readulog files or archive files, whatever it is, and putting into this file, which is known as trail files. You can see yellow files or three files, right? You put into a trail file. This is known as a trail file. Extract trail files. Now there is one more process known as a data pump. There's a data pump over here. This data pump will again read this trail file. Again read this trail file and send the data over here. Now what does that extract file should contain? Extract file should contain the database name, ID, username, password. How will it connect? It will need to connect to read the Readulog files. So it will need the database. It should be a user for GoldenGate. So I will use that user to connect to the database. Use that user to connect to the database in a username, password. Should have a DBA privileges. That user because it has to read the Readulog files. So it should have a DBA privileges for it. Username, password, and DBA. The username should have a DBA privileges. It reads from it and puts a trail file. Now it should also contain the location of this trail file. Right? Now this pump. Now what this pump should contain? Pump should contain this location of this trail file. That is fine. It should also contain the target. Target because it has to interact with the target. It needs to interact with target. So target manager IP address, machine IP address, port number of the manager. It has to interact first with the manager. Port number of the manager and target IP address. It also contains the location of the trail files in the target also. I tell you why. Okay. Location of the trail files in the target also. How does it? How extract works? It finds one transaction is committed. I did an insert into EMP values. This commit. It gets an alert. Commit has occurred. It created insert transaction into a trail file. It also gets to know because it is also thinking in trail file. It gets to know one record is committed over here, written over here. It reads the data. Now, for the first time when a connection is made, like a connection is made to a database, right? During a listener time, how does it work? It works with the listener. Now, data pump will go to the manager. Okay, I have made a connection to send the data. Manager will say yes. Data pump will contain the manager IP address, port number. Manager will start a process known as a collector over here to collect the data. Manager will get the intimation, right? Somebody sending the data. So let me start my process, collect the process. It will start the collector process. Till the time collector is down, collector is not down. Till the time you don't send the data. It starts the collector process. Now data pump will go and start sending the data to the collector now. The collector is a process. It doesn't containing anything. There is no file I configure for collector. No scripting, no nothing I configure for collector. Okay. So collector is not has no data, no script file for it. Data pump will supply the location where to write the data. Location. Okay. So data pump will supply to collector where to write data over in the trail file. Now this process which is replicate, it will read this trail file. Now convert these into commands, SQL commands. Because here in the to-do-log file, what does it contain? It contains the data. Insert contains the complete row. Update contains the old data, new data. Delete contains the complete row. Okay. But all these rows need to be converted into commands, right? So it will get to No, this there is insert, there is update, there is delete, to get the exact command for it and convert into an exact command and fires them on the target. Okay. So replicate what should replicate should contain? It should contain the target connection. It has to do insert, update, delete, create table, create index, all those things in all the schemas, in any of the schema, because command can come in any of the schema. So it should have access like create any table, select any table, delete any table, insert any table, right? What should it contain? A DB privileges, right? This user should contain a DB privileges, anyhow. Okay. So it is reading over trail file, converting into SQL commands, firing them on the target. So it should contain the DB privileges for it. So it is doing a lot of hard work you can see, because conversion itself takes the most amount of time, whatever it is. If the network is good, then this network everything is slow. Everything works fine. Only this is slow. Generally this process is slow. Okay. Because conversion of into a SQL commands is the most resource consuming process. Okay. Because these are generally simple lines, simple data. So you get to know if you insert, how to insert it, update it, delete it. Okay. So this is taking time, so it will take, this process is slow. Okay. Now one more thing. This is written optional. This file and data form is written optional. Why it is optional and what should be done? You might be thinking that why to create so many files over here, so many files over here. Extract can directly send the data to the collector. Extract can directly send data to the collector, and anyways the files can be formed over here. Yeah, this is the way which can be done also. Okay. This components are optional. I might not be able to, I might not need it. Because extract can directly read the data from the pool of files, send the data to the target. It should contain all the parameters like target IP address, manager, port number, everything. Just send it. Right? It can be also done. It's also one of the options, but this is not a good option practically. Why? First of all, I'm putting a lot of burden on the extract process. Like my extract can be slow. It has to read the data also, send the data also. So putting a burden on it, it's something like always we prefer to segregate the things, separate the things, so that if one thing is down, at least something is working. Next thing is the network dependency. Network dependency. How? So if my network is down, what will happen? Extract will read, but not able to send. Where it will store the data? It is not able to store the data at all. Right? It is not able to store the data at all anywhere in the local machine. So it will also crash because it will not able to do anything. It has no location to store the data in the source. Target, it is not able to send the data. It will crash. So network is down maybe for 1 day or 2 days or 3 days, right? Or maybe 2 to 3 hours maybe. So that readle of files would have been gone into archive files. That pointer would have gone to archive files. Now when I start my network, start my data, it has to go to the archive file to get read the data. We generally know that archive files generally are placed in the stored disk. Okay, it's generally placed on the stored disk. So that is not preferable to it. Might be the archive files are purged. They have a purging technology, purges every 3 months, 3 hours or 4 hours or 6 hours maybe. Moreover, there will be more delay in replication because it has to read the data also, send the data also. What if my pump is there? If my pump is there, what will happen? Network is down. At least these files have been created. I'm creating these files. I'm creating this file. Data from might read it after 3 hours or 4 hours. At least I'm reading the data. I'm working with the same page with database. Database is as databases are changing the rule of files. I'm also changing the pointers. I'm moving with the same page with the database. I'm not lagging anywhere. Good exact process. Once network is up, it will be immediately send the data. Extract has to read the data. Okay. This is just a risk. Okay, this is a risk. Okay, risk in case depending on the archive policy, and also a risk in case generally GoldenGate admin and database admins are different. So generally you have a database operation team, different database operation team. So in that cases, if this assumed network is down, you might need to communicate with the database team also to get the archive files or to check the location of the archive files. All such things, all such headaches will come. Okay. To avoid all these things, we can deploy, but not a mandatory. If you don't want, you don't need to. You don't need it. So then one more process, taking one more memory, taking maybe 50 MB or 100 MB in the RAM again. So if you don't want, you think that I don't want to put any more burden. Anyways, my database is small, replication is less, no much change is happening in my database. Maybe read log switches even happen in 2 hours or 3 hours. Even network is down for 2 or 3 hours. My read log switches are not happening that often also. Okay. So in that case, it is fine. You can just do extract and start sending it. Okay. It depend on the way. So generally, preferably, it is there. Okay. Just a moment. Hello. All your data is supplied with the pump process, what it has to read and what has to write, where has to read. So nothing is stored, no parameter in the collector process. Trail files are the files you just stored in the canonical format in the source or target. I think that I share the recording soon. Okay, so trail files are something which is there is the source and the target both. So in the source it is known as in the source it is known as extract trail file, that is a local trail file, and the target date is known as the remote trail file. Okay, the target is known as, and the format it is canonical format. Okay, if it is exists in the local system known as the extract trail, or remote trail will exist in the target system. So RMT trail is the target system, source system ext trail. Okay. So generally, what it does means that when I have to type any command, I will type in the source system. If I want to refer, the target it is known as the RMT trail, remote trail, it's a remote machine, right? If I am referring in the local machine, it is known as the ext trail. Okay. Whether in the source or target doesn't matter. Data pumps, we know that sending the data to the target are known as the secondary extract points, right? So they are the secondary extract. It is a secondary extract because it is also reading some data, right? It is also reading some data, right? It is also reading some data. It is also extracting the data, maybe from the trail file, but it's also reading the data. This is an optional component. If data pump is not used, then extract send data via TCP/IP to the remote target. So if data pump is not configured, extract will directly send the data. When data pump is configured, the data pump, the primary instruction will write to the local trail, and then this trail is read by the data pump. It will write to the local trail, read by the data pump, and send over the network. In the absence of data pump, the data that the extract process resides in memory alone, and there is no storage of this data in the system. So if there is data pump is not configured, then there will be issues in case of network failures. Checkpoints. So these are the main important thing which we are talking about. I think you have a lot of questions on that. Okay. So checkpoint is a thing where it is storing the data. So these are the files where it will store the data. Okay. These are the files where it will store the data. Store the data means store where it is reading. So there will be a checkpoint in the source file. Like source file means in the read log files. Okay, the checkpoint of the trail files where it is reading the data, and the checkpoint of the target where it is writing the data. So extract, where the extract is reading. Okay. So data pump is a thing we discussed here, right? This is the data pump. This is the data pump. So what does the data pump is doing? Data pump is reading the data from the trail file, sending it to the target system. So this is an optional component. If it is not there, then directly extract can send the data to the target. Okay. Also known as the secondary extract. Secondary extract mechanism. Why? Because it is also extracting the data. Okay. See, these both processes are extract only. These are both are extract only. This is known as the capture process. This is known as the data pump. Okay. But both are extract because both are extracting the data. Right. And if it is not configured, then the primary extract will send the data to the target. Right. So the absence of data pump, what's happened? The data pump is not there. Then extract will crash. There is no storage in the source, so there should be issue. There is a network of the target failures. There could be cases where primary extract abandons. You will why it will abandon because not able to send the data. It is sending the data, giving the error. Network is not there. And if how it will read it because there is no place to store the data, so it will abandon. Okay. Which position we are. So what it is reading, if it is crashes, how does it start the same time? Okay. Just assume that process crashes or database crash maybe. The database crash that has happened. Okay. The application is replicating the data. Okay. So the database crash and replicator will also crash. Okay, where it will connect because it's a connection mechanism. It is connecting to the target. So how does it know that where it has to start? Which trail file it has to read? Right. So you just assume I'm talking about, just go back to the diagram over here. Replicate database is crash target. So replicate will also crash, right? Because it's a connection to the target. So but these trail files are becoming like getting more and more and more. These keep on piling up. Okay, these keep on piling up. Right. So when I will start this replicate, when database is up, and then I have to start this replicate as well. So how does it know that which trail file it was reading, at which position it was? Okay. So all these things are came from checkpoints. Okay. Similarly, this database is crashed as well. Assume this database crashed. Now extract is also down. Okay, because it is also connection to the source database. So we will get to know how to read, where to read. So what is the problem? So next time it is also storing in some checkpoints. Similar data pump also. Data pump is also reading these state files. So also store all these positions. Every record has a position. Every record is identified in all in RBA. Okay. RBA. Okay. RBA stands for redo byte address. So these are the bytes. Okay. Value is byte only. Bytes. So in the trail file you will find it in the redo block RBA. So it keeps a position known as RBA. Keeps a sequence number of the trail files. These trail files works like redo log, not redo log file, but you can say redo log file only. It's a specified size, and the default size is 100 MB. This trail file keep on piling up. Okay, one trail file is completed, then it goes to the next trail file. It also has a sequence number, just like your archive files or your log files. So it has a sequence number. So it's keep on increasing its sequence number. Once 100 MB is reached, it goes to the new file, goes to the new file, goes to the new file. Okay, nothing like archive file, no backups. Okay, no backup. The keep on number is keep on increasing. Okay, you can purge the old files once it is read, once it is not required. So you can purge it manually. Okay, all these files. So everything has a sequence number and an RBA. All this information is stored in the checkpoints. Okay. Every process, this. All the four processes are linked to the checkpoint, where it is reading, where it is writing, what is the position. Keep on storing the checkpoints internally. Okay. You need not to manage it actually. It will automatically manage by GoldenGate. It knows where it has to read and where it has to write. So you need not to manage it. It will automatically will be managed. Right. So by default size is 100 MB, but you can change the size also. Okay. The default size is 100 MB. You can change the size. You can increase or decrease your wish. Okay. These are all checkpoints. So in the source we have checkpoint files. we have checkpoint files, but in the target, we have an option to keep it in the files or keep it in the table also. Table in the target database. We can maintain a checkpoint table in the target database and keep it there. Okay. Okay. Because replicate has a complete access. You know that replicate has a complete access, right, in the target database. And DB privileges. So it can create a table anywhere. So you can maintain a table in the target database, or you can also use files. But in the source, we have only files. We have only checkpoint files, which is there in the GoldenGate home directory. Okay. Data source. What is data source? Where we are getting the data from another data source. From where we are getting the data, we are getting the data from the review log files, transaction log files, vendor access module. These all are, this is just a term, okay, term used in GoldenGate data source. Okay. So database is the data source. Groups. Each process, we don't call it as a process, we call it as groups. So everything is group in GoldenGate. So everything is used now known as the groups. Okay. So extract is a group, replicate is a group. Okay. So what do you say? What do you call it? What is the group name? What is the extract group name? Somebody will ask you, what is the extract group name in your GoldenGate? What is the pump group name? What is the replicate group name? Okay. This is known as not known as the processes, but as groups. So we can have multiple groups also. It's not that I can configure only one extract, one collector, one replicate. Collector anyways I'm not configuring. I can have multiple extracts. Maybe I have 50 schemas which I want to replicate. I can put 10 schemas in one extract, 10 in one, 10 in one, 10 in one. So I have 5 extracts. Similarly, replicate also I can put 5, or maybe I divide it further. I make it 10. I have made it how many? 5 in the source, 5 extract. I can make 10 replicates. I can put not 10 schemas. I put 5x schemas. Okay. So it is there for more parallel processing. So somebody can ask you how many extract groups. So group is a keyword, or the group is a keyword is used. Nothing importance of it. Don't use process. Okay. Now GGSCI is a file which is GGSCI is a command interface like your Unix shell where you write all your commands to GoldenGate. Because it's GoldenGate, so it's a soft. Full form is command interface. GGSCI full form is command interface. So we'll do all your programming, everything over here. So maybe from tomorrow onwards, we would be starting working on the GGSCI itself. Okay. We'll first install GoldenGate and we'll see the GGSCI mode and start working on it. Then we have parameter files. Parameter files are the script files which we create for each process. Okay, these are the scripting files which we create for each process. Okay, so these are the what do you say? These are the script files where we'll write all the commands which we want to use for that process. So we have to this is the parameter scripting files for the GoldenGate. So we have two types of files. One is the runtime and one is the global file. Runtime is when we start the process, then it will be used. Global file is something just like a bash profile file. Okay, a bash profile file. How does a bash profile file works in Unix? Whenever you log in, it executes. Right. Similarly, whenever you log into the GoldenGate in the GGSCI mode, it will get executed. Okay. So one is the global file, one is the runtime. So every group will have a runtime. Okay, every extract, replicate, pump will have a runtime parameter file. Okay. Any doubts till now? I might be going fast. Checkpoints were clear, right? Storing the position. Okay, in tables or in files. In files in source, tables and files in the target. This is not much important. GGSCI is the software command interface. Anyways, you'll do practically. Okay, so we will over there you get the GGSCI mode. Okay, you will get the GGSCI mode, and there you can do all your commands, you configure your parameter and everything. What about the parameter file? So parameter file is are the files where the script files for each group. Script file for each group. These files are known as runtime files. One file is the global file, okay, which would be executed once you log in into your GoldenGate. Then, okay, come to this point. We'll go back to it. Come to this point. Commit sequence number. What does a commit sequence number is? Commit sequence number is every commit will have a number in GoldenGate. As commits are occurring, number will keep on incrementing to identify what all is there. So as per your commits, a number will be incremented, and this is known as the commit sequence number. So the identifier where my position is. Okay, because you know that GoldenGate is only picking up the committed transactions. Okay. So then identify the Oracle GoldenGate. What is the bullet point? Then enter the Oracle GoldenGate constructs to identify a source transaction. So it's kind of identifying a point in time or identifying where the position is, which point I have reached. Internally, it will get it. It will match it from the SCA number, but it is a different number. Okay, SCA number is a different number. System change number is a different number. Even there is no commit occurring, still you can see in this database SCN is incrementing. Okay, but CSN doesn't increment. CSN will increment only for commit occurs. Okay. Now GoldenGate do two tasks. One is the change synchronization, which is very important, which is main meant for, which is the selling point of it. One is the initial load. Okay, initial load is a special run, which is not that much mature tool as export and import. You can pick the data in a table, but there is no option where you can put some conditions or maybe pick other data. You can pick only tables. You can't even read the structure of the table also. So very restricted thing, not much use, but there is an option to do an initial load also with GoldenGate. Then, but you have to prepare because GoldenGate initial load is only used because what happens is export when you are doing replication between Oracle database, you can use export and import. You can use RMAN. But what about if I'm using replication from SQL Server to Oracle or Sybase to Oracle? So then we might be using GoldenGate. Why are we using initial load of GoldenGate? We have to use initial load of GoldenGate to pick up the data. But there is definitely an issue that we have to build up a structure manually over here. Maybe manually or maybe using any tool of code or SQL developer, and then we can do an initial load. So it is not picking any indexes, any triggers or anything. It will just pick the data of the tables. Whatever table you specify, it will pick up the data and send it to the target as it is. Okay. That is the initial load. Change synchronization we are doing anyways. Okay. So good question. No logging. So no logging cannot be used with GoldenGate. You have to do logging with the database. You have to do a force logging. You have to set alter database force logging before you start using GoldenGate synchronization. You have to enable your archives before you start your GoldenGate. So even if you don't enable your archives, then it will not do it. You have to enable the supplemental logging whenever you do your GoldenGate application. Supplemental logging is something in Oracle database. What is there? There is a concept of chained rows, and there is a concept of migrated rows. So these rows are not tracked in the rule of files. Okay, but these need to be a part of the rule of files. That's why we have to enable the minimum supplemental logging in case of Oracle database. So there is one more supplemental logging we have to enable for primary keys. So each table that will be covered in the next topic actually. Okay, maybe the next topic, and tomorrow I will discuss supplemental logging for the details. Okay, because anyways we have to cover it. Okay, so these supplemental logging, all these things we have to add it. So some pressure would be there in the database. It's not like Not at all impacted. It is not at all impacted in the sense that database GoldenGate is reading from the redo log file, so it is not interfering with the database anyways. However, the database is running fast or slow, it is not impacting, it is reading outside of the database redo log files. Right? So
Yeah, this is Tariq. Sorry, I did supplemental logging explain